Alright guys, welcome back to another one of our videos. This one we're going to go back to the normal kind, so we're actually going to do a lesson a day. We're not doing biology, haven't had any requests for that, but I did get a math request, so we're going to be doing, let's see, this one's Algebra 1, I think A, graph slopes, and Y-intercepts. Alright, so this is in Unit 2 of Algebra 1A. So let's start with just defining what these are. So you guys know what a graph is. A graph is a picture of an equation, right? So like I would write you an equation and then you would have to graph it somehow. So let's talk about what slopes and y-intercepts are. So we're going to be graphing primarily lines. So a line is in the form y equals mx plus b. Okay? Where the m here stands for slope. Don't ask me why, I actually don't know that. Uh, You'd think they'd pick a different letter, but yeah, they picked M. And then B here is the Y-intercept. Okay? I'm going to shorten it to Y-int. That's your Y-intercept. Now let's define what both of these things actually are. Here's a slope. Slope is you've probably heard this before, your rise over your run. I should have done this in a different color actually, so let's go ahead and switch color. Screw it. I'll finish slope in this color and then I'll do y-intercept in a different color. But yeah, so slope is just your rise over run, or it's your how high did you go versus how far over. That's really all it is. How high versus how far over. Okay? So let me give you an example graph. So let's say I have this graph. So let's give you a graph. Let's do this one in green. And sorry it's so shaky, I don't know why, but this table's really unstable, but I was getting really weird feedback and I've had to retry this video a couple of times now. So here's a graph, and we're going to put a couple dots. We're going to make this one 1, 2, up 1, 2. So this is going to be 2, comma 2. And then we're going to have another dot down here at -1, comma 2, -1, comma -2. All right, so let's see if I can't get this cap in. -1, comma -2. All right, so we've got 2, 2. That's a 2. It's hard to see. 2, comma 2, and -1, comma 2, these two dots. So if we were to connect them with a line, we would have to find slope and y-intercept and all that jazz. So let's talk about these slope to begin with. So here's slope. I'm going to do it back in black because I did slope in black. So it's how high versus how far over. So you went from oh, you can't see that on screen. There we go. You went from -1, right? So you went from -1 all the way over to a +2. So you started over here, -1. All right, here's -1, right? All the way over to +2. All right, so -1 to +2. So let's go ahead and count the spaces. This is 1 spot, 2 spots, 3 spots away. You could also do this by saying -1, 0, 1, 2, that kind of thing. So you stop when you get like at there, so you don't count -1 because you started there, right? So you go, well, -1 goes to 0, 0 goes to +1, 1 goes to +2, so you end up having a difference of 3. Okay, so 2 and -1 are 3 spots away from each other. One other way to do that is with a word. I'm sorry, not a word, a number line. So you go like this. You're like, all right, well, here's 0, so here's put 1, here's 2, here's -1, -2, and you move from -1, you moved all the way over to 2. So how many spots are in between? There's 1 spot, 2 spot, 3 spots in between. Okay, so a lot of different ways. The idea is you're really just counting on a number line how far away they are. So -1 and +2 are 3 spots away. So is that your rise or run? So you moved your x-axis. So you saw that I pointed at a dot from the left and I pointed at a line from the right. From left to right, is that rising or running? This one might be kind of weird, but rising would obviously be up and down, right? So it's running over. It's going over this way. So that's going to be our bottom number. That 3 that you just found is going to be our bottom number. All right? So let's talk about our top number. That's going to be our rise. Well, we drop from here's -2. All right, -2, all the way up to +2. So -2 is how far from +2? Well, we can use the same line graph actually. So we can go from -2 to +2. So instead of this one just being 3, we're just going one more, right? So this one must be 4. So our slope here is a 4 over 3. And how you know it's positive is because your line goes upwards. So you'll notice, and you kind of can't see it, but if you drew that line, it would go upwards. You're always going to count left to right, and if it goes upwards to the right, that means you're going to have a positive slope. If the line points downwards, then that's going to be a negative slope. Alright? So slope is just rise over run. It's how high over how far away. And you don't need to worry about positives and negatives till the very, very end. Is your line going up? It's positive. Is your line going down? It's negative. Alright? So that's slope in a nutshell. Let's talk about your y-intercepts. Let's move on. And I'm going to use a different color. Oh, it left all sorts of dots. Darn, well, whatever. That's okay. You guys will still understand what's going on, so it's all good. So let's see. What color should I use here? Let's go with, I have pink. Alright, pink's going to be your y-intercept. Y-intercept. Okay, so the y-intercept is defined as where the line touches the y-axis. Okay, so let's say I had a graph. So I'm going to graph a graph. We're going to use blue for this. And here's my graph. Alright, just like, you know what, I'm going to remove the papers from underneath because my markers are bleeding through them and I don't want you guys to keep seeing all these weird little dots. So y-intercept again is where the line touches the y-axis. So let's go ahead and get an example problem. Alright, remember this is your x-axis, this is your y. Alright, y goes up and down, x goes left and right. So anyway, let's go ahead and draw a graph that looks kind of like this. Alright. So you'll notice that this line obviously touches our y-axis, our vertical line, and it touches right here. X marks the spot, right? Where that little dot that I made was, or that little X. So this is where it touches it. That is your y-intercept. So if I told you that this was at -1, that must mean that the y-intercept here, or B, is equal to -1. Is all that means. So y-intercept literally means where your graph touches one of the axes. In this case, the y-axis. Alright, so we're talking about the y-intercept, so it's where it crosses the y-axis. Okay, so that is the y-axis in a nutshell. What I'm going to do is I'm going to go over to your application and take a look at some of the problems, and then we'll run through any ones that I think are entirely worth running through. So finding y-intercept should be easy. Just figure out where it crosses, okay? I'm going to show you actually one other way because I see in your application that you may have to calculate y-intercept. So let me teach you a different way of calculating the y-intercept. Here we go. So let's say I gave you an equation. Y equals, let's say 4x plus 1. Alright, there's a wonderful, simple little equation, right? So y equals 4x plus 1. Remember, you have an m, which is your slope. And then you have a b, which is your y-intercept. Alright? If I ask you about your y-intercept for this equation, obviously it's whatever this is. So it's a positive 1. Your y-intercept here must be the positive 1. Okay? So that's all it is. When they give you the equation, you already know your slope and y-intercept. That makes life real easy. If they give you the graph, it's not much harder. Here it is. So in this equation, it would have been, so this would have been something like y equals, I don't know, x minus 1 is really all this would have been. And that's actually kind of bleeding in, so let me go ahead and mark that off so it's easier to see. But yeah, so that one would have been something like y equals x minus 1 because it is a -1 in y-intercept, and it goes probably up 1 over 1, up 1 over 1. Not exactly, but you get the idea. So that is how to find the y-intercept in two different ways. The technical way of how you know this bottom thing is the y-intercept, I'll show you how to run through that real quickly. So let me go ahead and do that in orange marker. There we go. So in orange marker, let's go ahead. What you're really doing when you're finding the y-intercept for x plus 1 is you're saying, okay, well, I need to find where it touches y, which must mean on the y-axis, any of these points, x is 0. What I mean by that is right here, that's 0, 0. So both of these are 0 in that case, right? But what if I went up here and I made that 1? That's 0, 1. This point down here, that is 0, -1. You'll notice that all of these start with 0, and remember that you read your coordinates as x, y, or 0, 1, 0, 0, 0, -1. So you'll notice that the x never changes. So if I ask you for a y-intercept, all I'm asking you to do is take your equation, whatever it might be. Okay, that slid. So go ahead and take your equation, and you're just going to plug in 0 for x. And this is going to be pretty easy math, but it's okay. You're going to get the idea. So y is equal to 4 times, and instead of x, I want you to plug in a 0. You know, barely looks different, the red and the orange, so I should probably not do that anymore. But anyway, so what is 4 times 0? Yeah, 4 times 0 is just 0. So your final equation here is just y equals 1. So that is your y-intercept. All you do is plug in 0 for x, and you will get your y-intercept. With lines, this is a lot easier. This will actually become a much more important concept later on, which is why I thought I'd show it to you now. But for the most part, this is all you have to do. Okay? So feel free to refer back to my notes for any of these. I'm going to go find like a more complex problem on your application, and I'm going to run through it with you. Let's see. It's unfortunate, but a lot of your application has things like pictures like this. So give me one sec. I'm gonna see how I should do this. I think I'll just draw kind of a rougher draft for you. Do I have a pen? No, I don't. Okay. I'm gonna draw kind of a rough draft for you and explain how all of this works. All right. So let me give you a full problem. This is typically what you're going to do. This is actually a very simple chapter. So let's go ahead and draw a big XY graph. So here's, again, that's X, that's Y, that's an X. It's a crap X, but that's okay. So X and Y, right? And we're just going to add some coordinates. So let's go with 1, 2, 3, 4, 5, -1, -2, -3, -4, -5, -1, -2, -3, -4, -5, +1, +2, +3, +4, +5. Okay, so this is our XY graph, and then now we're going to add a line to here. So I'm going to use pink for my line. Let's say I've got a point. Say I've got a point 3, 3, and then I've got another point -3, -3. Okay, we're going to do a real simple one. And to do that, I'm just going to draw a line between these two, just like that. All right. So what they're going to ask you is, what is your slope and what's your y-intercept? And they're going to do it in a multiple choice version. Let me go ahead and lift this camera up a bit. There we go. Alright, so they're going to give you a multiple choice thing for this, but it's pretty simple to figure all this out. So let's talk about the y-intercept. First off, where does it touch the y-axis? Might be confusing, and you might have already noticed, but you'll notice that the y-axis is this vertical line. Where does that pink line touch the black? And you'll notice it's right here, right smack dab in the middle. So what is that point that's right in the middle? So your y-intercept, I'm going to include this down here, y-intercept is, and you're exactly right, is going to be 0, 0. That point right in the middle is nothing, nothing. You haven't moved anywhere. So in this case, your y-intercept would have been 0, 0. Next, you're going to have to, put in your, let's find our slope, okay? So we just got to pick 2 points. Now, you can pick any 2 points you want. You could have picked this point way out here at -3, -3, and this point up here, 3, +3. Or what's easier is I would personally use 0, 0. Okay, so 0, 0 is really easy to use. Sorry, that was my phone. But 0, 0 is super easy to use because this is all that happens. Let's start with 0. Okay, how far up do you have to get from 0 to 3? To 3. All right, so let's do our rise first. From 0 to 3, it's 1 spot, 2 spot, 3 spots up. So our rise is 3. Oh, you guys can't see that. There you go. Our rise is 3. Now, let's talk about our run. So it went from 0 again to 3. So let's talk about it. It's 1 spot, 2 spot, 3 spots away. So your run, or your over, whatever you want to call it, is going to be 3 more. All right? That must mean that this slope is rise over run, or 3 over 3, which is just 1. Okay? So your slope is up 1 over 1. Up 1, over 1, up 1, over 1, up 1, over 1, etc., etc., etc. And we keep following that same path. But this slope was just 1. And you know it's a positive because your line is going upwards. All right? It's going to rise upwards here. All good? So that is how your problems are going to work for this entire tutorial. It will get slightly more complex, so I'll probably be releasing a video soon for the follow-up. All right? Let me know if you need anything. If not, go ahead and wait on my next video. It should be up in the next hour or so. All right. Best of luck. Bye.